The title of my talk is Introduction to Flux. And it's supposed to be at MunichJS Meetup, but I thought, well, it felt more like conference with 200 people coming. So I thought I changed that. The other thing that I changed is I changed the title a bit from Introduction to Flux to From MVC to Flux, because this is also the title that I handed in as a JSConf proposal, and this is sort of the test run that I'm going to give there. So let's get into it. Hi, my name is Julian, as Alex already told me. I do open source, mostly JavaScript, since 2009. I started in the Mozilla projects. I worked on Bespin, which was a canvas-based code editor, and maybe implement the first GUI with Canvas. We ditched it because of accessibility issues. Then worked on PDFJS, which is kind of the PDF viewer that you have in Firefox, and other related projects. Currently, I study computer science at ETH Zurich. And in my free time, I do swimming, I run marathons, and in the summer, I do an internship at Facebook. So part of this talk was about getting me to really think a little bit more about the technology that Facebook is doing and look a little bit more into Flux. So before I get started, there's an interesting quote here that I just want to put out there as a kind of back thought, and then later on, I think after the talk, hopefully it makes sense. So it's by Ben, and it states, application development isn't about clever architecture or even abstraction. It's about complete control of data flow through your code. Okay, so if you wonder what does this have to do with Flux? When I prepared the first draft of this presentation in Zurich, I asked someone, what do you think about Flux? And the answer was kind of, yeah, I heard about Flux, it's cool. It's a hot topic, but I heard it's really hard to get your head around it. And that's also the first experience that I had, because Flux, it feels different, it feels natural, but if you come with the MVC kind of picture in your mind, it's hard to make the gap to how you would rewrite your application in Flux. So this presentation is really focusing on trying to make this step over as smoothly as possible and explain it. So Flux, if you would try to define it in a few words, it's basically a principle for building scalable, dynamic data-driven applications. And because it's a principle, you can really use it in multiple cases. So Flux is normally maybe thought of, you have to use React, but it turns out there are a lot of blog posts where people say you can also use Flux together, for example, with Backbone, which is, well, an MVC framework that's been around for a long time. Or even that you can bind it together with, you know, this other competitor, AngularJS. And in that case, the blog post claims that Flux helped them scaling the application. You can even apply the concept further. So that is from the React conference in 2015, where Pete Hunt basically talked about applying the Flux principles to full stack Flux, to use all buzzwords that are out there, to basically try to apply the Flux principles on the server and then on the client, and also has some pretty cool theoretical background, so you should check this out. And the important thing that you see here is Flux, if you apply it to so many different use cases and it still works, it seems to solve a fundamental software development issue here. So let's see what that could be. And there is a quote from Dijkstra. He's one of the maybe best or most amazing computer scientists we ever had for distributed computing. And he had a famous quote, the art of programming is the art of organizing complexity and avoiding its bastard chaos as effectively as possible. And Flux is basically doing this. So if you think about, well, so what can go wrong if you write MVC applications? What can, you know, where can get into chaos state? So let's see. So here is an app, and I put these letters, the M, the V, and C. And let's say we have a simple one where you only have like one box for the model, which I call data, one for the view, and one for the controller. And if you read an MVC book, you would say, okay, the interaction is defined like this. You have a view, which talks to a controller, and they talk back and forth. And then the controller basically talks back to the model, so the data, and then all live happily together and form an app. So that's nice. It turns out, in reality, you often have a connection between the model and the view, or data and the view. Does someone of you have an idea what that could be? Yes, so that's like Axel says, it's like two-way data binding. So in this case, it might seem kind of okay. So what is the problem with MVC? This still looks manageable. Well, the problem starts if you grow this app a little bit bigger. Suddenly you have more components and you have a lot of possible interactions. And this is not a problem about like smart developers versus non-smart developers. When I was doing my internship here at Munich in Google, we were working on a new front-side app and built components. And basically 2 days into the project, I started grabbing a piece of paper and drawing what is the interaction, and when events get fired here, redraw this. And so you really get into the state really easily. So the question is, and also the app that we had before, I don't think this is an app anymore. I think that's more the spaghetti app, like what you maybe know from spaghetti code that you write. So let's say what are the kind of two main problems that we have here. The first problem is there are many possible paths that you have in this program. So for instance, let's say we start down there and then we follow all these arrows until we stop somewhere. So you see this is like one possible path where the interaction can flow. The problem is if you want to write now a test for this application, you need to cover all possible interactions. So all possible paths there. Is there anyone in the room that wants to do testing for all these kind of interactions? So please raise your hand. I just do this okay, there are a few. You're really brave because I guess the number grows exponential. So, I mean, this is pretty good if you want to have a solid shop for test writing, but it's nothing that really scales for large code bases. So that's sort of one problem. It gets really hard to understand what the interactions are because, you would need to cover all these. The other problem is that you have cascading updates or side effects. And also this is a problem if your application changes. So for instance, let's say you have these two components. They are written by the first developer, and if you just look at them, it's like super easy, okay? And then a second developer comes along, and it draws in this new connection between the data and the controller. And suddenly you see there are now more paths connected. And this seems easy to spot on the slides, but every line of code that you add to your code that glues together two parts that were not together before can cause huge new side effects and kind of, you need to write either a lot of new tests or hope nothing happens. But in reality, when there's something that can happen to fail, it will fail. That's kind of the rule of large applications if you want. So if you want to think about the app complexity, what we saw before, if you only have like one slide, the app complexity is kind of, it's still okay. But if we then go to larger apps, the complexity really grows immensely. And also the problem is there's sort of a barrier where, as a developer would say, okay, this is now too complex, I cannot understand, I cannot reason about it. But you don't normally, I never saw a developer going to his manager and saying, okay, I think we crossed the point where this app is too complex for me, can I please go to a different project? It's something that, then later, if you're in this, later on, if you're like 2 months in this red barrier and you see kind of tests failing and whatever, sort of, okay, maybe we should do something, but it's really hard to spot and to see. So maybe there would be a way to always keep to the left and keep the application simple. So let's say maybe nature can help us here. That's a little bit strange, but actually sometimes it's good to look at nature. So here, we have two kinds of species. On the left-hand side, we have insects, and on the right-hand side, we have marvels. Insects don't scale. So if you think about the largest insects that we found on Earth are back to the dinosaurs, and I thought it's like half a meter or 80 centimeters, like a flying thing about this size. And mammals, like if you think about big walls, they can get pretty huge. So they seem to scale. Does any one of you know what's the big difference that makes one system scale and the other doesn't? So biology, kind of back? No, but so the inner parts is a good way to look for. Heat? No, that's not it. Veins. Veins. What's the problem with veins?
Because the issue insects don't have veins, so the fluid is like flowing around, and
Yes, so your colleague basically nailed it. So just for the recording, so in insects you basically have a circulatory system, what it's called. So you basically the stuff in there just floats around somewhere, and then if it gets to the right place, you're lucky. And that's basically what we do with our app development. And on the right side, you have veins where really the blood goes to the spot where you want to do. Makes it a little bit more complicated, but more efficient. And that lets you scale up. So if we now think about what we want here, basically solution is to enforce that instead of building a large app, we want to have smaller apps, like three smaller apps that we can control. And the question is now, how can we ensure to get there? So that we always and only have like these smaller pieces, and also that there's no kind of going further across this line. And there's another parallel. So if you think about how can you make sure that a city is clean always? And one solution would be, okay, you pass a law that littering is disallowed, so you basically state some rule, but that's not enough. What's also important is that you then basically enforce this law or these rules. So the first part would be just saying you have a styling guideline saying, okay, you're not allowed to do blah, 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 but it turns out that, yeah, as I said, if you just make a rule, someone will violate it and you will crash. So you need to have an enforcement in place. Just saying, I think there's a better solution. Just teach the people why it's good to not litter instead of enforcing and beating people up. But yeah, for software development, I think having a good type system or a runtime system enforcing sort of law is maybe more, works better. So let's talk about Flux. So the question is, starting from this kind of spaghetti app, how can we arrive now at a Flux app that hopefully scales better? And the two restrictions that Flux invokes is first that the information that we have in our app passing only flows in one direction. So far all the arrows here basically can go to both sides. And the second important part is that there can be only a single action at any point in time, which makes it easier to reason about time evolution. And now we look into these in detail. So we first concentrate on the first part, where we want now basically have the data flowing one direction. And the goal is basically remove all arrows that have two sides and just end up with arrows that go in one side, such that we have one direction. And for simplicity, I also simplify it down to this case. And now we can think about this. Where do we want to split? Where do we want to basically draw the arrows? Either we draw it to the right, or we draw all to the left. And if you think about it, the data in the view interaction gives you guidance what should be the answer. So should the view always basically update the data, or does it make more sense that the view basically pulls the data and then re-renders? And it seems the last case is more likely, that basically the data should be kind of the canonical information that is in your app, and you just update the view. So that means that the arrows should all go in this direction. Okay, now if we add back the second layer, we can basically think about all the arrows in between. So do we need this arrow at all? I mean, two views, if they have a controller, they maybe can communicate via the controller. So, well, maybe we just remove that at all. What else do we got? We got this one. So we said before that views talk towards the controllers, so we shift that towards the controller. And let's see what else we got. Okay, here in this case it's not so clear what direction we want to have, so in this case we really must make a choice, kind of which data should depend on which other one, and we make the choice that should go this way. And now we arrived basically by a little bit of thinking that in this case all the information only flows in one direction. So if you think about where we started with these kind of arrows in two directions, we already made it simpler going to this step. But we can go further and now apply some observations. So what we see is that the controller basically only controls the data now, and the data only control the views. So maybe it would make sense to rename the things and bind them a little bit together. And that's basically what stores are about. So basically, instead of having the data and the controller separate, the idea is that now we have a new concept called store that has the state, so basically the data that is in your app, and also the business logic, which does the changes on the app, on the data, all bind together. So we say, okay, we take the data and the controller bit and we fuse them together as stores. So this now, on this overview slide, we basically have the next iteration and we now arrive at this model. For sure, it's easier to just flip some arrows and then you're fine. So you need to do some implementation work. But it turns out that once you understand why it's good to follow this, it falls out naturally. So now that we have this, and because it's late, we can play a game, right? So we can play App Flipper Ping Pong. You know, this flipper machines where you have this ball and then you need to get a higher score, so we can do the same thing here. So you just, you know, you just flow the information through your system and you can bounce back and forth. And I mean, that sounds funny, but that might be still show, well, there's still an open issue. Basically, we have not prevented cascading updates yet. We know now that it's easier to see how the information flows, but still it could happen that one update triggers the other and it's hard to determine the side effects. And the solution for this one is basically, instead of having these updates implicit, we make them explicit and call them actions. And we also add a gatekeeper that says you can only have like one action passing through the system at the same time. And that then basically gives this kind of, that the fuse, instead of talking to the stores directly, they basically split out actions. And then we basically have this gatekeeper, which we call dispatcher. The dispatcher then takes the action, gives them to the stores, and then if there's an update from the store, it propagates to the fuse. And we will see a more detailed example soon. The important restriction is here, there can be only one of these actions at the same time. So for example, if we say the upper few creates an action, we dispatch it to the dispatcher, goes through the store, and now the lower few in the same runtime loop sends another action and sends it to the dispatcher to throw it into the system. The system will say, oh no, you're already doing one action and you can only do one action at a time. You get a runtime JavaScript error, and then you can start debugging your JavaScript, kind of look at why is there a cascading update happening, and then fix that problem. So yeah, it seems kind of we managed to enforce the two restrictions that we wanted. So information only flows in one direction, and there's only one single action at a time. And hopefully you agree that this diagram looks simpler now than where we started with all these crazy errors and whatever. If you think about how does the server component fit in there, it's really simple to model here, because you can say a server basically creates actions again, and these actions then get dispatched to your dispatcher, and that updates your entire app. So from a developer point of view, it doesn't matter where the actions come in because of a user interaction or where they come in from the server. And that allows you to decouple your implementation from the actual details and lets you scale. Also an interesting question is kind of, so before I ask you who wants to write unit tests for these cases, I know the concept is still a bit in flux, but who thinks this is cleaner and would be more likely to write unit tests, or more liberal to more hands, luckily, okay. That's a kind of, okay, you're still here and seems to be useful. Okay, thanks. So the recall kind of, okay, we started up there with our spaghetti app and we now got to the Flux app. So yeah, so let's talk a little bit more about details. So it turns out, I'm sorry, I was a little bit lying to you. So the picture up there is kind of what you normally get if you look at the Flux application. But to really understand, I think it's better to look a little bit more into depth. But it's still simple, so no worries. So the one thing that I want to point out is the interaction between stores and fuse. So over there, I just made an arrow, but let's make this a little bit more explicit what's happening on there. So basically, the fuse are only pretty decoupled with the stores. So the fuse basically, they observe the stores that they want to pull data from, and they only listen to change events. And if there is a change event, the only way that the view can get data from the store is by a getter function on the stores. So that means, you have this nice decoupling that you can develop your views and your view components independent of the data source, which is always, or lets you then later scale and develop the components independently, as we will see soon. The other thing is, the views are not allowed to basically do anything with the stores that trigger an internal update to the stores. If you want to change the store in any way, you need to send an action through the system. The only interaction that is allowed between the view and the store is really either basically listen for change events or pull data out, but never push data directly in. The other thing is then basically the action part to the dispatcher. There's also a little bit different. So a view, basically the only point where you want to create a new action is when there's an interaction. So for example, if a user toggled on a tree view item, you want an action to be created. And then instead of sending out the actions directly, you basically talk to what is called an action creator. And this action creator then can perform different operations. So for example, if you think about any kind of, you make a request to the server, you might want to have an action creator that models this one task about like, fetch me all the current files in this directory. So you would call an action director with the path that you want to look up, and then the action creator internally, it would basically start performing an XHR request to the server, so make this request to the server, and you would create a first kind of action. And the action would might be say, okay, I made a file request, and it's starting at this point. And as a payload, you maybe say the file that you want to request from the server. And then what you do is you build in this bin there over there for the dispatcher, and now you play a little bit ping pong again. So basically you throw this action to the dispatcher, and then the dispatcher applies it to all the stores. The stores can consume this information that you have in the action and then update themselves. And the stores can update themselves because the business logic is encoded in there. Now basically from the XHR request that we made, we maybe get a response. And for this one, then we send a second action through the system. And in this case, we would say, okay, the type is now field request, and it's succeeded. And as payload, we say again, okay, we have this in this file name, and the content is I love MunichJS, for instance. And then we do the same thing again. We throw it against the dispatcher, and then the information goes there again. What is important to note is that the actions that we basically throw in there are always completely computed. So this is a little bit fuzzy words, but the rule of thumb is there should be no promises or any kind of outstanding data in there. You should be able to serialize the actions completely. The problem is otherwise, if you, let's say you have a promise in this action, you throw it against the dispatcher and you have it in the stores, you make your system basically listening to a hidden side effect again, which is kind of a bomb that's now sitting in the stores, and at some point this promise is going to get triggered, and then it causes an update, but it's really hard to track when this is going to happen. So that's why you need this action creator that basically encapsulate all these things, and then if there's an update, really send out an explicit update message via actions. Okay, so these were defined details. And this is kind of what I would say as practical rules that you can write down, that you only update stores through actions. The views basically start refreshing when there's a store change event or sort of thing. And the views only query data from stores via getter actions. And when we have all these restrictions in place and follow these best practices, it really happens that kind of modular apps fall out naturally. So this is kind of, it feels magic, but once you start following this guidance and you try to do anything that is not modular, normally you end up having two actions triggered at the same time, and you get a runtime exception. And therefore, it seems kind of the only way they can end up with. And also, this really avoids common kind of errors, kind of triggered updates, making your app too complex. It really feels kind of a restriction that feels naturally and useful, and that helps you to scale your app. So in the last 5 minutes or so, I want to show a little bit like a few examples. This is an example of the live coding that I did back in Zurich about a simple file tree that uses Flux. And the code is on GitHub. I also implemented it using 2 different Flux implementation, and it's based on Webpack. So if you basically want to get started, and maybe beside having the Facebook chat implementation of Flux, maybe look at a different example that might be something that you find worth looking into. And what we want to do here is basically we have the list of files, and it's like, yeah, I guess you all know a file tree, right? You can click on there, and then it expands, and it shows what files are below this root. Yes? 5 more minutes. Okay, cool. So in this case, if we basically click on this link, what happens is we detect there's an on-toggle event. We call to this action creator that in this case is create listdir action. So listdir is kind of the Unix command of show me what files are in there. It would create a few of actions, like the first for the begin, and then maybe when the payload arrives. We throw this against the dispatcher. We then update our file system store, where we have kind of what files have we loaded from server already. And then this allows us, basically, we trigger a change event, and then on the right-hand side, this causes our view to update, and basically we can now draw the expanded views with the files in there. The nice thing about this is you can implement this in a way that the binding between the stores and the view is decoupled. So what I did in the implementation, and that follows this Medium blog post by Learn React, is this idea about React container components. So as we saw before, in React you have the components, which is like HTML, and then we have like an outer file tree controller, and inside we have the file tree entries. And the file tree entries themselves, they don't know about how to talk to store or anything. The data is really basically passed in from this controller that sits outside, and that talks to the stores. So therefore, the individual file entries can be developed independently from what kind of store you use. And to glue them together, you basically just wrap them with another component around. And then you see, if you have the normal toggle event, you create an action, you throw it against the dispatcher again, then you update all the stores. The store trigger an update on the file tree container controller, which is around, and that then causes the update to all the file tree entries inside. Another cool thing that you can do with this Flux architecture is basically you can record your actions and replay. So because, as I point out, it's important that your actions, you can serialize them. So there's a blog post about it, and I recommend you read it, as that basically when you're running the system, you record all the actions that go to the dispatcher, and then if you want to replay, it's basically really just about playing them out again. So, and then your app, if you develop it nicely and covered all the side effects that are good covered in this blog post, you end up in the same state as you were when you hit a bug. So as an app developer, you normally spend a lot of time kind of just getting to the point where your app crashed again, then see if your bug fix worked. And this basically helps you speed up. Also, it's interesting for test integration, because you just record these actions, and then you can have an integration test where you have like 10 actions, they just play after each other, and at the end you see what's the outcome. There's a little bit of a problem with the single, that you only allow to have a single action in your system. It prevents a lot of coding padding errors, but it seems to be not so obvious at first how to work around this. But from my experience, it really turned out that Flux was right in the end, and what I was trying to do was not modular. So a common problem that we have, for example, in this list view, is you have a view like one of these entries, and you want to toggle them. So let's say it's like an on-expand. You create an action, and then somewhere when you expand it, you want to do another drawing. So you have a view, And basically, for example, if you on an initial render, it would create a second action. And this is bad because you have cascading updates. So the fix for this would be, instead of having the second action being triggered at the end, you basically pull it to the front. So on expand, you're not only triggering the second action, but you do the first one and the second one at the same time. So that needs a little bit of rewriting, and you need to make a little bit more explicit what's happening, but it makes predicting your app much more easier. So if you think about how to get Flux, if you do npm install Flux to get the main Facebook implementation, it turns out you only get a dispatcher, which is a little bit confusing at first. But that's really because Flux is such a core principle, it leaves a lot of space to other implementations. This is sort of implementations that you might want to look at. The top one is the one from Facebook, and he kills me soon, so I need to hurry up. The ones that I would focus on is basically Flumux is pretty interesting because it doesn't add too much weight, but still keeps or provides you with the basic ingredients that makes you happy. And it's also what I have covered in example. So if you build an app, it's basically picking one guys on the left, picking some other bytes, and then flew them together. And the cool thing is that Flux is so flexible that you can do this. So what Flux felt to me is it's really nice. That coupling of models and controllers into stores is naturally, it really makes scaling apps easier, really easier to think about and easier to write tests, which is important. So the summary would be, Flux is not an implementation, which is really hard, which is really important to get away. It's a philosophy or principle. Data flows in one direction and one action at the same time. And your app is really, you take Flux and you need to bind something else to there, which well, basically allows you to take an existing app and just modify a little bit or come up with something new. And Flux really gives you a good guidance to make sure you do the right thing, you make an app that can scale, but you still can go your own way. So thank you, and I'm happy to take questions.